Hello everyone. Today I will train artificial neural networks, multi-layer perceptron using a hyper technique, and I will use particle swarm optimization method and gradient descent method. One particle swarm optimization method is a method used in global optimization, and gradient descent method is used for local optimization. uh, you can combine the benefit of the two methods together, and you will get a very good result. Okay, this is our data. Simply it's a sine wave. Let's see. Okay, this is our data, and I want to train the the neural network to copy this pattern. Okay, so this is my code. Here you can define how much hidden layer you need in the multi-layer perceptron, and here you can define how many neurons in each layer, and here is the number of inputs and the number of outputs, and there are some parameters which is very important to define. If you look for the gradient descent method, you will see you have learning rate, which is very important parameter. This parameter control how much fast the training of the network. And for the particle swarm optimization method, you have W and C, which is which are very important also parameters. So inside my code you can define those parameters. Here is the parameters for the gradient descent. First you define the learning rate. Here I define the learning rate as 0.5, and here you define how much data you will use in the gradient descent method. So I will use all of the data with the gradient descent method, because gradient descent method is very fast method. And for the PSO method, I will only use 800 sample for the PSO method, because it's not a fast algorithm. Okay, and here you can define the number of the populations and the parameter W and C1 and C2, and let's start now the code and see the results. Okay, run. Most probably this code will take certain amount of time, because it's a heavy algorithm. So let's wait to see the result. Okay, the PSO algorithm take about 1 minute, and the gradient descent method take about half half second. So okay, I think it's a good response. Here you can see the mean square error of the network in the PSO, Very good. Oh, this graph is destroyed because I didn't close the first figure, but this show for each population the mean square error here you can see is near the zero for each sample. Okay, let's change the parameters and see the result. Okay, I will take only 600 and I will change this to 0.6. Okay, let's start again. Okay, here is the data. Let's start. Okay, here you can see the PSO take 37 seconds and the gradient descent take about half second. Okay, so let's see. Nice tracking. And here is the mean square error for the PSO. Sorry, this is the mean square error for the PSO. You can see most of each population the result of the mean square error is near the zero. Okay,